Hello, and welcome to the Cochlear Implant Hackathon. My name is Leah Muller, and in this presentation, I'll give you a high-level overview of the hackathon. Let's first consider how we hear sounds, and we'll apply that to the steps you'll see in the hackathon. Sounds enter the external ear and progress to the cochlea, where they are transformed into electrical signals that travel to the brain and are perceived as sound. In the case of the cochlear implant, the ear is bypassed by the implant. An external microphone takes in the sound goes through a processor and then triggers electrical stimulation of the cochlear nerve that passes those signals up to the brain as before. For more on how cochlear implants work, see Andrew Oxenham's presentation on hearing and cochlear implants. For the hackathon, we take this one step further and bypass the hardware and software of the cochlear implant with code. The cochlear implant processor is replaced with your code for the hackathon. This processes the sound and tells the stimulator which electrodes to stimulate and when. Then the vocoder simulates the neural connection from the cochlea to the brain. For more information about the vocoder, please see Jordan Bimes' presentation. Now let's put this framework into a more detailed look at the hackathon. I'll refer to this diagram throughout the presentation and go over each box separately. I've put in here the sound, also known as the acoustic input, the bypass of the cochlear implant, and a representation again of the vocoder as the neural simulation. Let's begin. We can start with the sound, also known as the acoustic input. We'll provide you with audio files to play with while you're hacking. The acoustic inputs we'll judge in the hackathon belong to the following 4 categories. They are consonant nucleus consonant words, natural speech, speech and noise, and music. Consonant nucleus consonant words, or CNC words, are words that begin with a consonant, have a vowel sound or nucleus in the middle, and end in another consonant. They're simple one-syllable words that are commonly used to test cochlear implant users' hearing through a cochlear implant. Next is natural speech. Because natural speech is so important, it is the stimulus that most cochlear implants target with their algorithms. One of the hardest situations for a cochlear implant user is understanding speech and noise, so distinguishing speech and noise is an important milestone for improvement. Finally, there's music. Cochlear implant users usually don't enjoy music to the same extent as prior to implant, which indicates that there's improvement to be made here. An improvement in music processing would greatly improve CI users' experience. Sounds enter the cochlear implant, and remember we're replacing the cochlear implant itself with the code that you contribute through the hackathon. Advanced Bionics has generously provided some base code in MATLAB and Python as a starting place for you to work with. Check out our code review presentation by Philip Herman for more info on this. The output of this code is the stimulation instruction for the electrode array of the cochlear implant. In this case, the output of your code is this instruction as a matrix of stimulation pulses in units of current amplitude. The size of the array is the number of electrodes by the units of time. Matrices in this format are what your team will ultimately submit for judging. Leading up to final entry, we'll provide you with sounds you can use to test your code. You'll input the sound to your code, and the output will be a matrix of stimulation pulses. We also supply you with the vocoder, which is again the simulation of how the initial sound would be perceived through a cochlear implant. If you input the matrix you created to the vocoder, the output is a sound that you can listen to. You can test your algorithm by running the output matrix through the vocoder, listening to the resulting sound, and changing your code to improve that sound. When it's time to submit final entries for judging, we will provide you with new sounds that your algorithms haven't seen before. If you've used the sounds provided leading up to final entry, these new sounds that we provide for final judging will be similar but not the same as were provided for training. You will be given 12 new sounds, 3 for each category, and you will be asked to use them as inputs to your code and submit the output matrices. Upon submission, we run your output through our vocoder, which is the same one you were provided, so no surprises there. We get an acoustic output for every entry. These sounds will be used for judging. Once the deadline for submissions has passed, teams cannot submit any new entries. The hackathon then moves on to the judging rounds. Judging is covered in more depth in a separate presentation, but the high points are that both hackers and the general public can sign up to listen to sounds created during the hackathon and judge how good they sound. This is a powerful tool for getting accurate ratings of teams' performance while spreading out the task of judging to many people. Coming out of the judging rounds, we will have a ranked performance of teams' algorithms. Top teams for each category will go through a code review with the organizers of the event. The top teams will submit their code and also explain their strategy to the event organizers. Top algorithms will be decided by event organizers and must demonstrate good performance in all 4 sound categories, as well as significant improvement in 1 or more categories. Coming out of internal judging and code review, the top 3 algorithms overall will be decided. Prizes. First place is $5,000 to the winning team overall. Second place is $2,000, and third place team gets $1,000. There is also a better than baseline winner by category. If your team is ranked first in category and it performs better than the AB Gold Standard base code, and if your team has not already claimed one of the top 3 prizes, then your team will receive $250. In addition, and this is an unprecedented and exciting prize in itself, top teams will have the opportunity to further develop their algorithms with advanced bionics and UCSF and test with real cochlear implant patients in the future. Thank you for watching, and good luck.